Yes, hello. Good evening. This is teacher Leonard Chamtai. I am going to take you through introduction to heat for senior 3, and we are going to go through this together. The topic is understanding heat for senior 3 physics. Um, it's presented by Mr. Chamtai Leonard, teacher at Kapchora Senior Secondary School, teaching physics and ICT. First and foremost, we look at introduction to heat. That's in our slide number 1. Shall be looking at introduction to heat. And from here, we say that heat is a form of energy that causes substances to change temperature or state. So that is a brief definition of heat. It's a form of energy that causes substances to change temperature or change state. And this is caused by the differences in temperature. So that is a definition that I've captured here. We have the sources of heat. One of it is the sun. It produces heat energy. Electricity also produces heat energy. Then friction. When you rub objects together, it also produces heat energy. Then when we proceed to this other slide, the key areas of our study shall be concentrating on some of these areas, though we may not exhaust all of them, but we shall concentrate on a few of them. Heat and temperature, we shall also look at heat capacity. We shall then go to unspecific capacity, latent heat, applications of heat capacity, specific capacity, and latent heat in daily life. We shall also look at refrigeration and cooling, evaporation and its effects. Basically, the areas that we are going to concentrate much on will be heat and temperature, heat capacity and specific capacity, latent heat, and then applications in daily life. So those are some of the areas that we shall center our discussion to. We have heat capacity, the definition of heat capacity. So from here, this is the amount of heat required to raise the temperature of a body by 1 degrees Celsius, or is the amount of heat required to raise the temperature of a body by 1 Kelvin. All that will be correct, no problem there. The formula for heat capacity is denoted by the letter C, which is equal to the amount of heat or the quantity of heat times the change in temperature. This Q is the amount of heat, and this is delta T, which is the change in temperature as the temperature changes from one value to the other. Units of heat capacity is joules per degree Celsius or joules per Kelvin. That's what we have here, joules per Kelvin. Specific capacity is our next term. How do we define that? The heat required to raise 1 kilogram mass of a substance by 1 degree Celsius or by 1 Kelvin. The formula for specific capacity is given as Q is equal to mc dt. So where Q is a quantity of heat, this is the mass. We are talking about raising 1 kilogram mass of a substance by 1 Kelvin or 1 degree Celsius, where m is a mass, c is a specific heat capacity, which is this, and then the change in temperature. So meaning our c will be see the subject in this part. We divide both sides by m delta t. So ideally we are going to have our c will be equal to q over m delta t. Okay, so examples, water has a specific capacity of that in degrees Celsius. in kelvins, I mean in joules per kilogram per Kelvin, we shall be having 4200. That is not captured here yet. Copper has that value. Okay, so we have a table comparing specific heat capacities of different materials. We have them here. We have a material, we have the state, then the specific heat, and then the thermal behavior highlights. So each of these is captured. We have water, the liquid state, that is a specific heat. It is very high. It is behavior, thermal behavior, very high, excellent for thermal regulation. Ice is solid, has that specific heat, 2.09. Thermal behavior, it is lower than liquid water and still retains it well. So you can follow all that. So here we have a video. You can follow this video. Let's play this video. This video gives us an experiment of heating different materials. Okay. Here we have 3 spoons, metallic and plastic. We have 3 cups. Yes, we can go through that. So we have metallic, we have plastic, and then we have wooden spoon. We are pouring hot water in each glass. Be careful when touching it, because it can burn. Add more hot water. Wait a little longer. You want to observe what happens to the oil. As the metal spoon gets hotter, the butter begins to melt. So you discover that this one is melting more faster compared to this. You can see what's happening here. No change on the plastic and wooden spoons. They are just the way they were first. What can you conclude from this experiment? So you discovered that this spoon conducts heat much more fast. It's a good conductor of heat. The metal is a good conductor of heat, while wood and plastic are good insulators. It takes so long and they don't even conduct at all. Conductor allows it to pass through it, while an insulator does not allow it to pass through it. Okay, so there are so many videos of that nature online. So latent heat is our next term to look at. Definition of this: latent heat is the heat absorbed or released during a change of state. Now this happens without changing the temperature. Okay, it happens without changing temperature. Heat is absorbed or it's released during the change of state, but the temperature of the body does not change. There are 2 types basically: latent heat of fusion, change of solid to liquid, liquid to gas. And then we have latent heat of vaporization, liquid to gas, and then gas back to liquid. The formula is that Q, which is the amount of heat, is equal to mass times the specific latent heat. Now with the specific, either latent heat of fusion or latent heat of vaporization. Okay, so this one now you can fit in based on what you're looking at a particular time. If you're getting the quantity of heat in relation to specific latent heat of fusion, it will be Q is equal to ml LOF. Then if it is specific latent of vaporization, it will be Q is equal to mLOV. Okay, so applications of latent heat. One is melting ice in drinks, boiling water for cooking, steaming or steam ironing process, and many others. A summary, an assessment of this. We'll look at the recap of what we have been talking about heat as a form of energy that is transferred between systems due to temperature differences, and as the amount of heat required to raise temperature of the body by 1 degree Celsius or 1 Kelvin, that is heat capacity. And there's a quick quiz for us here. What is latent heat? Give one example of heat capacity in daily life. So reflect on how it affects your environment. At this point, I want to thank you for following and being a very good audience. Thank you, and thank you. I remain Leonard Chimtai, a teacher of physics at Kapchora Senior Secondary School. Thank you. Bye-bye for now.